Right. Good afternoon, guys. Thanks for joining us today. My name is Karthik Vishnath. I'm a product manager AWS. I manage the VPC, Direct Connect VPN platforms. So today we're going to talk to you about, I should actually say more, Pinterest. Jamie Cox from Pinterest is going to talk to you about their road from migrating from Classic to VPC. But I want to spend about 5 minutes to talk to you guys with some of the questions that I get asked as a product manager when customers are trying to migrate from Classic to VPC. Just a quick show of hands. How many of you all are running in Classic environment? Yes, quite a few. How many of you all are running VPC only or hybrid VPC only? Okay, so very few of you all. Okay, so most of you are in Classic. So the biggest question I asked that I asked as a product manager is like, when should I adopt VPC? Right? I'm happy with Classic. Things are going great. When should I adopt VPC? There's no real timeline per se. I think that's something that's important to understand. We still have a lot of customers running on Classic. We're going to support customers when they're on Classic. But the way I at least answer that question is I turn it around and ask, why do you want to move to VPC? Or sometimes even I'm asked the question is, why should I adopt VPC? So Jamie will go into a lot more of the details, but at a very high level, it's your classic benefits with VPC. It's simple. It gives you a lot more flexibility in terms of hybrid environments, and there's a lot more security features with VPC, and we're investing heavily in VPC. It's like, I think for those of you who were in the talk with Becky Weiss presented about VPC, you can see there's a plethora of benefits that VPC provides. And then the next question that I get asked is like, okay, well, now that I understand the benefits of VPC, how do I go about the process? I'm actually not going to talk about that, and that's exactly why we have the session. But the one key, going back to the first question, is like, when should I adopt VPC? A lot of it depends on your use case. Like, what are you trying to achieve? One thing which I tell customers is, take a look at what VPC has to offer for you. I think I want you to start there. The newer instance types, the performance, as well as some of the newer features that you get with VPC. So take a look at that. From a timeline perspective, there's no timeline. There's no particular timeline that you need to follow. It's not like Classic is going away. Classic is going to be around. So we will continue to support Classic until we have customers running on Classic. Right? With that, let me introduce Jamie Cox, who's the architect in cloud computing at Pinterest.
Thank you. So there are 4 things we're going to be talking about today. The first of them is why, some of the reasons you might want to migrate into VPC from Classic. The second one is how, some of the tools, processes, and procedures you can use to do that migration. The third one is timelines and schedules for the migration. And then the last one is some of the lessons that we have learned during the migration process. Pinterest helps people discover the things they love and encourages them to do those things. We have over 100 million pinners around the world. We do over 150,000 requests per second at peak, and we are 100% in Amazon EC2. So some of the benefits of migrating to VPC. There are some significant performance differences between Classic and VPC. In EC2-Classic, we hit about 250,000 packets per second. With enhanced networking and SRIOV, inside VPC, we can do close to 1 million packets per second. Inside Classic, we can't quite get wire speed, but VPC, we're able to use almost the entire 10 gigabits on the larger instance sizes. VPC allows you to create internal-only ELBs, so we have been able to replace our clusters of HA proxy or Nginx nodes using DNS round robin with internal-only ELB to save some costs because we have less servers, and the health checks can actually be a little different as well. There are clearly some security benefits inside VPC. So for example, they allow you to create private endpoints. One of them that's available today is S3. You can actually attach policies to these endpoints, and these policies have a very descriptive language that gives you a lot more control over exactly who and how that endpoint can be accessed. you have full control of the IP address space inside VPC. You control the subnets. When you launch servers, you can specify the private IP address that you want that server to have. If you need to relaunch it, you can specify that a new node can get that same IP address. You control all of the IP address space, which is very handy. And of course, there are NACLs, network level access controls, that can be applied to subnets. So there are also some access differences within VPC. You can have private peering between VPCs, either your own VPCs or customer or partner VPCs. In addition, you can have very high-speed direct connect links directly into your private data center, into VPC. And of course, your virtual private gateway allows for VPN access, either for clients or HQ or something like that. So some of the tools. Because Pinterest it has global reach, any migration that we would undertake would require zero downtime. In addition, if we wanted to do a hard cutover, we would have had to duplicate about 40% of our infrastructure for a significant period of time. That would have been fairly expensive. Luckily, Amazon has built this ClassicLink tool. I just want to give a shout out to the ClassicLink team. This tool has performed exactly as advertised, letting us do essentially phased migration with zero downtime. It's been awesome. So, like I was saying, ClassicLink essentially lets you address the private IP address space of your EC2-Classic nodes directly from VPC. So this means you can have private IP address to private IP address connectivity for all your services. This essentially lets you do a phased migration without having to do any type of hard cutover. One of the important parts to remember is that EC2-Classic uses the 10/8 IP address range. So if you want to continue to use the 10 range inside VPC, you have to use 10.0 or 10.1. Also remember that if you have direct connect as well, you don't want to have overlapping IP address space in your private data center either. Because you cannot specify the ClassicLink connection information in your standard AWS run instance commands, definitely spend some time to get your automation set up to automatically set up ClassicLink on your new nodes as they're being launched in Classic. We happen to use Puppet for our config management system, so we initiated some Puppet rules, Puppet classes specifically to do that. You can also duplicate this functionality inside autoscaling groups. I think there's one other way to do it, but I forget what it was. So service discovery. Before you can begin migrating your services, clearly you need to know exactly what they are and what the dependencies are. So take some time and effort before you begin the migration process to build out service discovery within your organization. There are some great open source tools for doing this. The cloud engineering team spent a couple days basically putting together netstat and nmap tools, and then exporting that information to HTML so that we could have kind of a clear view of what our service discovery looks like. There's also paid products that do this for you. The reason that you need to know this information is two parts. First is the dependency tree, knowing which services depend on other services. And of course, what the actual ports that those services talk on. When you're building security groups, you need to know this information. We've also found it extremely useful to track all the different components required for a migration. We happen to use Jira for our ticket tracking system. So we essentially institute a process where we create a master ticket for each service that is going to be migrated, and then we have subtasks related to each of the different migration components. You can have communication in many different forms. Sometimes it's face-to-face, sometimes over email or chat. It's important that you capture all that information and make sure it's in the migration ticket for that status. There's a single place you can kind of reference exactly what is going on with that service. We've also found it very useful to track the migration progress and rate. So we've set goals, and the only way to know if you're actually going to reach those goals is if you track the total number of instances that have been migrated. We also found it useful to track the velocity as well, to know if you're accelerating into that curve or if you're falling off of it. And then, of course, tracking problems and the resolutions so that you can fix those and not repeat them when additional services are being migrated. Continuous improvement. It's important to take the time to think about each of the different pieces of VPC and spend some design effort laying them out before you begin the migration process. So for example, NAT gateways. Every private subnet, any services launched in those private subnets need to transition through a NAT gateway for internet egress. So it's important to think about where your subnets are and what services are going to land in each subnet and what the internet egress for those different services is going to be. If you make your subnets too large and you have too many services in there, it is possible that you may need multiple NAT gateways depending on TCP connections and bandwidth, and that can be tricky to set up. So spend some time, think about that, and design it correctly from the get-go. So subnets also fall into this same thing. You basically only get one chance to get your subnets right. Once you've launched instances inside them, you can't make any material changes to those subnets unless you migrate all the instances out, and then you can make changes, but that can be difficult to do. So think about the layout of all the services, what subnets they're going to land in, not only from the perspective of what's the existing size of that service and how many hosts does it have, but what is the future growth of that service? How many new hosts are going to be added over time? In addition, think about where new services are going to land. Ideally, your organization is continuing to grow and you're going to have lots of new services. Think about where they will live within your subnets. In addition, if you have specific services that require a lot of internet egress, you're doing a web crawl or something like that, think about placing those inside public subnets. Public subnets transition through your internet gateway, not a single point of failure, no bandwidth limitations, so great if it needs high-speed internet egress. So security groups have a limited number of rules that you can apply to each security group, and then there are a limited number of security groups you can apply to each host. So it's a constrained resource. Really think carefully about how you're going to lay out the rule sets for your security groups. If possible, when you're laying out your subnets, think about laying them out in contiguous IP address blocks so that you can actually use CIDR-based rules inside your security groups for specific service access privileges. So instead of creating a security group to security group rule, you can actually create a CIDR-based rule that's based on IP addresses that could condense the total number of rules required. In addition, obviously, you need to plan for access from the EC2-Classic IP address range. So gathering information and documenting each service is an important step. Ideally, you do this before you begin the migration process. It's designed to basically aid that process and make it much simpler. One of the things we did at Pinterest was we created a service template. So service owners go and click a button, and it basically brings up all the information that they're going to need to fill out for their service migration. So this includes documenting the current setup, lists of hosts, service dependencies, and of course changes that are going to be required in migrating from Classic into VPC. So for example, in Classic, when you're launching instances, you specify the security group by the name, you specify the AZ it's going to be launched in. In VPC, you have to specify security groups by the security group ID, and you specify a subnet. Subnets contain the AZs. And of course, important things like does data need to be migrated as part of this process? Also, capturing service dependencies, very important. There are what I call hard dependencies. So if service A depends on service B is down, that will affect service A. That's a hard dependency. But there are also soft dependencies. Things like monitoring access or SSH access. Not having those available means your service still works, but you want to make sure that those are captured as well so you can grant access at some point. Part of that service migration plan is the things like runbooks and monitors and alerts for that service so that you have a place to go during the service migration process. You can understand the health of that service. And of course, canarying and testing the launching of new hosts inside VPC. So what is the success criteria? How do I enable traffic to that new service? And of course, ideally, you have acceptance tests that will be run against those new services, those new hosts, to make sure that service is functioning correctly. Also, it's important to understand what the finish of that migration looks like, right? What does a full rollout, what does the complete migration out of Classic and into VPC look like, particularly to understand if you need to roll back. What are the rollback criteria? When will you stop trying to fix forward inside VPC and just migrate it back into Classic? And what are those steps? So it's important to capture this information before you begin the process so that if you encounter issues or problems, you know exactly what to do. So there's essentially 3 types of services that you're going to encounter during the migration process. The first one we'll talk about are stateful clusters. So these contain data that need to be migrated out of Classic and into VPC. The standard way of handling this is you essentially spin up replication slaves inside VPC, you turn on replication, you make sure the data is migrated, and then you can decom your Classic hosts. There are nuances depending on the actual storage system, but most of those should be captured in the migration templates. The second one is stateless services. So these don't have any data that needs to be transferred. Ideally, this is a very straightforward process. You spin up a new VPC pool, you begin to grow its capacity, you shrink your Classic capacity until eventually it goes to 0. So migrating your front-end traffic can be a little tricky. We found that using DNS weights to be extremely effective. Essentially, you create your new VPC ELB, you register your new VPC hosts with it, and then you go and you create additional entries for that VPC ELB. Initially, you assign the weight to be 0, and you have your Classic set to 100%, and then you just begin to shift that traffic. Change your VPC to 10%, let it run for a while, 20%, et cetera. One thing to think about is that you should probably keep your Classic ELB around for a while. There are a lot of clients on the internet who will cache your DNS information and your IP address information for longer than the TTL, or forever in some cases. So definitely monitor your Classic ELB to make sure traffic has shifted away. Otherwise, you may have to track down the owners of that traffic, basically go talk to them and let them know that you've made some changes and have them refresh their DNS of their clients. So timelines. Building a dependency tree is very important. This doesn't mean that you have to lay out every single dependency within your entire organization. Essentially, what you're trying to capture are direct dependencies. So if service A depends on service B, you want to make sure not to migrate them at the same time. The reason is that if they're both in the migration process and service A is having problems, sometimes it's difficult to understand if it's because of VPC migration or because service B is having an issue. But if you simply separate those, it makes that troubleshooting much easier. Of course, it's also important to schedule each of those different services. You don't have to create a master schedule that lists out every single service in the entire timeline. You basically need to schedule the dependent services so that you can understand when and how they're going to be migrated. And of course, meet regularly to kind of track that progress. Speaking of tracking, one of the really important things to do is to figure out how you're going to be tracking the migration process. Create a tagging system or some other classification system that lets you understand your existing Classic service cluster size and what it's going to look like when it migrates into VPC. If you don't do this beforehand, it's really difficult to try to go back in time and reconstruct exactly when that migration process took place, how often you had duplicate services or servers. So if you come up with a methodology for tracking this beforehand, it'll make the migration process much simpler. And in addition, depending on your tagging system, it can make it very straightforward to pull costs of migration out as well. If you have a large, complex infrastructure like Pinterest does, you're going to be looking at this information regularly. So spend some time and effort on making tooling and dashboards so that you can let the rest of the organization and your own teams coordinate on this. And of course, service owners. So the service owner knows the most about a service, and they need to be intimately involved in the migration process. Ideally, they are the ones who are filling out the migration templates. If they are also going to be doing the migration, that's great, but sometimes they will simply fill out the template and a different group will come in and do the migration. So it's really important that you get onto your service owners' roadmaps, get into their quarterly planning, get into their sprints, make sure that they know exactly when they have to do all of these steps, and that they'll be around for when the migration is taking place if they're not doing it themselves. And once again, definitely use a master ticket so that you can capture all this information in a single place. Everyone can refer to that whenever they have questions about the process. So some of the lessons that we have learned during our migration process. You're already trying to change the wheels on your moving vehicle. Don't also try to change the engine at the same time. Limit the scope of changes. A lot of service owners will kind of take this opportunity to be like, oh great, we're migrating to VPC, we're going to have a whole new cluster of servers, let me change the version of the operating system or the version of Java or whatever. Try to encourage them not to do that. This is simply to eliminate variables that are going to be changing in case there are issues. So, if there is some problem with a service during the migration, if the operating system and everything else is the same, then it's very easy to track down what that issue is and remedy it. But if there's lots of variables, then it becomes very difficult to actually track down. So encourage them to limit the scope of changes where possible. So you have these new constructs inside VPC called network ACLs. These are optional, right? You still have security groups. They still function exactly the same way. Your security team may decide to use NACLs as part of their new toolkit, but they function significantly different than security groups. So make sure they have a complete understanding. And like I said, you don't have to use these. In particular, if you're spinning up the private S3 endpoints, the S3 endpoint continues to use the public IP addresses of S3. It doesn't use a private IP address inside your VPC space. So just understand that if you're going to be using NACLs. So service discovery really eases the migration process. If you have good service discovery in place, it's going to make building out security groups, understanding exactly what needs to migrate when and what the dependencies are is much easier. You absolutely have to have this information during the migration process when you're building your security groups. You need to know exactly what services, on what ports, or talking to other services. So spend some time and effort building out tooling. Ideally, it's automated so that if you have a long migration process and new services spin up during the middle of that migration process, they're automatically captured within your tooling. And when service owners go to fill out their template, they can go look at the service discovery and be like, oh, great, my service is already in here. So subnets, I mentioned this before, but you really only get one chance to get it right. Once you've launched services inside these subnets, you really can't make any significant changes to them. So spend some quality time with subnets and planning out which services are going to land in which ones, the public versus the private ones based on internet egress. And ideally, think about laying them out in a contiguous IP address space so you can use CIDR-based rules inside your security groups. So speaking of security groups, definitely start with deny all and work your way towards open. One of the mistakes that we made is we started with some of our security groups in a wide open mode, migrated services in, and then when you when you go back and try to lock those down, it's very easy to deny legitimate traffic. So I definitely recommend starting with deny all. As soon as you migrate a service in, you open up the known ports, and you will know immediately if that service is working or not, because it will be denied traffic if you haven't opened all the ports. So start with deny all, work your way towards open. So if you use the Amazon AWS.com DNS space, this is great in Classic. It provides split DNS. If you're outside EC2, you get the public IP address. If you're inside, you get the private IP address. Hosts inside VPC will always get the public IP address when they resolve this. So not necessarily a problem, but definitely understand that that's the way it works. It's different than inside Classic. So one of the great things about ClassicLink is that it literally lets you run in a mixed environment for as long as you want to. Pinterest has been in the migration process for over 6 months now, and during that portion, we have had large portions of our infrastructure running in a mixed mode. Half of it in Classic, half of it in VPC, and it works flawlessly. It almost works too well. So encourage your service owners to migrate into VPC. They're not going to gain all the benefits of VPC until they have finished that migration process. So kind of keep on them, make sure you get on their roadmaps, let them know about the benefits of VPC and why they want to migrate. So encourage them to do that migration. I guarantee you that someone within your organization cares very deeply about the cost, and particularly the cost of this migration. So just start tracking it from the very beginning. Make sure you have a tagging system in place that makes it very easy to capture this information. Ideally, build it in such a way that whoever within your organization cares about it can go and hit a web page or query that information easily. But definitely think about it from the beginning. Trying to go back and retroactively compute this information can be very tricky. So that is the end of my talk. I'm going to open up the floor for questions.